Hello everyone, this is Poonam and this is the ninth part of the chapter Electricity for class 10th. And we were solving the numericals on the series and parallel combination. We have the first question like this. This is the diagram and we have to solve the total resistance in the circuit, the total current in the circuit and the potential difference across R1. As we can see that there are three resistors R1, R2 and R3. R1 is 7.2, R2 is 8 ohm and R3 is 12 ohm. So in the first part, total resistance. To solve this total resistance, firstly we need to solve this R2 and R3 value, means the combination of these two first. So for this formula, 1 by R is equal to 1 by R2 plus 1 by R3. R2 is 8 ohm and R3 is 12 ohm. We will take LCM. The LCM will be 24. 8 3s are 24, 12 2s are 24. So we have 5 upon 24. By taking the reciprocal of this 1 by R, this is R, and reciprocal of this is 24 upon 5. We can convert it into the decimals. 5 4s are 20, 5 8s are 40. So it will be 4.8 ohm. That means resultant of this. So we can draw one more diagram for this resultant. This is R1 which is equal to 7.2 ohm, and now this is R2. This will be equal to 4.8 ohm. Means the resultant of this is 4.8. So we can draw it like this. Now these two resistances are in series. So the resistance will be equal to the resultant resistance in series. It is equal to R1 plus R2, and R1 is given 7.2 and R2 we have calculated is 4.8. 8 plus 2 10, 7 plus 4 11 and 1 12. So we get 12 ohm. So the first part means the total resistance in the circuit will be equal to the 12 ohm. Now the second part. In the second part, the total current in the circuit. The total current, we have the equivalent resistance of the circuit. That means this R will be equal to the 12 ohm. We have the potential difference also, which is given, that is the 6 volts. So according to Ohm's law, I is equal to V upon R. The value of V is 6 and R is 12, so it is equal to 1 by 2, or we can say 0.5 ampere. This will be the second part. Now according to in this third part, potential difference across R1. So now in the third part, we have the resistance is for the R1 only, that is equal to 7.2 ohm, and we have the current, total current in the circuit, that is equal to 0.5 ampere. Again we have Ohm's law, V is equal to IR. I is 0.5 and R is 7.2. We can solve it. We can write it 5 upon 10 and it is equal to 72 upon 10. 5 2s are 10, 2 1s are 2, 2 6 are 12, which is equal to 1.6 volts. So this 1.6 volt potential difference is for this 7.2 ohm resistance. This is the second numerical. Now this is the third numerical. Question is, show with the help of diagrams how you would connect three resistors, each of resistance 6 ohm. Means we have three resistors and the resistances are 6 ohm. That means we have R1 is equal to R2 is equal to R3, that is equal to 6 ohm. So in this question we have to find out the combination, resultant combination will be 9 ohm and 4 ohm. So there are two parts. In the first part, the resultant should be equal to 9 ohm. For this 9 ohm resistance, we need to combine these 3 6 ohm resistances in series as well as in parallel. So if we connect all the 3 in series, then 6 plus 6 plus 6, the total will be 18 ohm. So we cannot connect all the 3 resistors in series. And in the parallel combination, the resultant resistance should be equal to the less than 6, that is equal to 4. It can be possible, but we can calculate it. So for the first part, we need to connect these 3 resistance in 2 forms. In the first form, 2 series and 1 parallel, and in the second, 2 parallel and 1 series. 2 series, if we connect the rough, we are doing the rough work because we need to show with the help of diagrams only. If there will be 2 series combinations, that means suppose these are the 2 series and 1 in the parallel, like this. This is 6 ohm, this is 6 ohm, and this is 6 ohm. The resultant of this will be 1 by 6 plus 6, 12. So if we calculate 1 by 12 and 1 by 6, and in the series 2 parallel and 1 series, 2 parallel means this is 1 parallel and this is second parallel, and 1 in their series combination. So 6, 6 and 6, 1 by 6 and 1 by 6 and 6. This can be solved. So we can do these two, and let us see for this first part and second part which can be possible. So suppose firstly we are doing this. That means the 2 parallel combinations and 1 in their series, 6, 6 and 6. Firstly we need to solve this. So 1 by r is equal to 1 by 6 plus 1 by 6. LCM will be 6. 1 plus 1, 2 by 6, 1 by 3, and r will be equal to 3 ohm. 1 by r is equal to 1 by 3. We will take the reciprocal of this r and reciprocal of this. We get r is equal to 3 ohm. If r is equal to 3 ohm, this means this r will be equal to 3 ohm. So we have 1 r, this 3 ohm, and the second r in the series, that is equal to 6 ohm. So 6 plus 3, because these are in series combination, so the total resistance, resultant resistance will be equal to 3 plus 6, which is equal to 9 ohm. So for the first part, the diagram could be like this. In the second case, for the 4 ohm resistance, it must be this. So in the second part, 2 in the series combination, 2 resistances in series and 1 in their parallel, like this. 6 ohm, 6 ohm and 6 ohm. So we need to calculate firstly solve this. Resistance will be equal to 6 plus 6, that is equal to 12 ohm. Now this 12 ohm resultant is in the parallel of this 6. So we need to calculate 1 by r is equal to 1 by 12 plus 1 by 6. 1 by 12 plus 1 by 6, LCM will be 12. So 1 plus 2, 6 2s are 12, 3 upon 12, 3 1s are 3, 3 4s are 12. So we get 1 by r is equal to 1 by 4, or by taking the reciprocals on both sides, we get r is equal to 4 ohm. So in the first part, we need to combine 2 parallel and 1 series. In the second part, we need to connect 2 series and 1 parallel. So you can practice this type of questions, and these are from the NCERT book.